In this lab, we will do additional metrics. We will look at the population assignment to buildings in each area. So buildings, we want to report on potentially exposed populations. We want to report on potentially exposed populations to Alpine faults. We will base this on the relative area of the buildings in each SA2 admin area. This formula we will use building population equal. So we'll find the total population in each SA2 polygon, and then we multiply by building area in that SA2 area, SA2 polygon, and divide by total building area in SA2 polygon. So this is how we do that. So what we do is that we create a new column called area underscore meter squared equal, and that is buildings.geometry.area. So buildings data frame looks like this, and you can see that it has geometry, and if we plot buildings, just taking a bit of time here. So buildings are plotted over here, and if we plot with the background South Island, so let's have a look. So this one over here. So we'll just insert a new cell curve, and we plot that. Okay, so we have South Island, and the buildings are these blue dots on it, and you can see that it is very close to the Alpine Fault. Okay, so in this lab, what we are calculating is the building population that is exposed, the population that is exposed to Alpine Fault. And so what we will do is that for the geometry, we will find the area. So we have geometry looking like this, and when we do dot area, it finds the area of each of those multi-polygon. And we let the new column area underscore meter squared equal buildings dot geometry dot area. So on running this, so we'll have this. So area underscore meter squared equal this, and then we show calculations. So what we do is that we look at buildings where the SA2 name equal Berrytown. So, and then we find the area for the Berrytown, and then we sum them. So this is what happens. So buildings data frame is this one, and this one here, and what we do, we subset buildings where SA2 name equal Berrytown. Okay, so we subset that SA2 name equal Berrytown, and then we find the area underscore m squared, and we find the sum. So we get 204,707. Okay, so then we do buildings and we group by, yeah, so we group by equal SA2 name area dot sum, and that will give us the same value. So buildings group by equal SA2 and find the sum. So this is for Berrytown, and Berrytown is over here, and 204,707.723778. They are saying. So this is what we're doing over here. So compute total area of buildings in each SA2. So let building underscore area underscore summary equal buildings dot group by bracket by equal SA2 underscore name and square bracket area underscore m squared and dot sum open and close bracket. So for each of those SA2 areas, we have the total area. Then we rename area column to something more descriptive. So let building underscore area underscore summary dot name equal total building area in SA2. So what does the formula say? Total building area in SA2 polygon. So let's name it by that. Building area in SA2 polygon. And that is in square meters. So let's be it building underscore area underscore summary. So the name is total underscore building underscore area underscore in underscore SA2 underscore polygon underscore m squared. So get this, and let's check the name. So building underscore area underscore summary dot name, we check that, and you can see that the name is the same as we assigned. Then we display the column names of buildings to see what columns we have, and we display the column names of building underscore area underscore summary, but we have to look at the buildings underscore area underscore summary by converting it to pandas data frame. because at the moment it's in this form of here, and that is not there won't be the column names for that. So in order to look at the data frame form of that, we have to do pd.dataframe. So we get this. Okay. So now we join this to buildings data frame using pandas match. So buildings equal. So we had buildings data frame, and we're going to use the pandas to match. So pd.match open bracket and buildings comma buildings underscore area underscore summary comma, and we're going to use the outer join. So how equal outer comma on equal now the common columns. So the common columns are sa2 underscore name. So we'll have on equal sa2 underscore name and buildings dot head, printing that. So we have this total building underscore area. So the values are labeled, the values are over here, and it's labeled as total underscore building underscore area underscore in underscore sa2 underscore m squared, and sa2 underscore name is same. Then we look at the head of the admin areas. So looking at the head of the admin areas, we have the name of the columns, sa2 underscore name, sa2 underscore id, population 2018, and geometry. So what are we interested in from the admin areas data frame? So let's look at the formula again. So the formula says building area divided by total building area in SA2 polygon. So, and then multiply by a total population in a SA2 polygon. So this admin area gives the population. Sorry, the building area. Let's have a look. So admin area, it gives the population, and there is geometry as well. So what we need over here is from we need the population 2018 for each of SA2 name. So prepare appropriate columns in SA2 geodata frame for joining to buildings. So admin underscore areas underscore 2 underscore join equal admin underscore areas, and we dot drop open bracket columns equal square bracket geometry comma sa2 underscore id, and when we print that we got this. Then we prepare appropriate columns in SA2 geodata frame for joining to buildings. So we want the population 2018 to be renamed to total SA2 population 2018. So remember the population, the formula. We are calculating the population which is potentially exposed to Alpine faults, and this total population in a SA2 polygon is from these admin areas. So admin underscore areas underscore 2 underscore join dot rename open bracket columns equal open curly braces and pop 2018 colon this column, and we're going to rename that to total underscore SA2 underscore pop 2018, and when we print that the data frame looks like this. Then we join total population in each essay to buildings data frame. So buildings equal pandas dot match open bracket buildings comma admin underscore areas underscore to underscore join comma how equal outer, and on the column, which is the common column, SA2 underscore name. And when we look at the head, so we will have total SA2 underscore population over here. Then we compute relative population in each building. Can leave as fractions of percent for now. So let relative population underscore list equal empty array. So in each of the building building dot iter rows, open and close bracket columns, pop for I comma rows in buildings dot iteros open and close bracket in the column population equal so for each of the rows we will take the total SA2 population 2018 and we multiply by the area, which is in meters squared, and divide by total building area in SA2 we renamed as polygon underscore m squared. Then relative population list we append open bracket pop close bracket, and printing the relative population list we get this. Append back to buildings geodata frame. So buildings, and we add a new column called buildings underscore population 2018 equal relative population list. So it will print the relative population list over here. And buildings pop 2018, when we sum it, that equals to population 2018 column of sum of that column in admin areas data frame. Okay, so we check sum of the population from admin areas data frame equals sum of population assigned to buildings. So buildings, and then the name of the column buildings underscore pop 2018 dot sum open and close bracket equal admin underscore areas bracket pop 2018 dot sum open and close bracket, and it returns true. So they are equal.